In this video, I will discuss the other rules in finding the derivatives. In the previous video, I've discussed how to find the derivative of a constant, power, constant times a function, sum and difference of functions, product, and quotient. You can just check on Calculus playlist to watch the lesson. And in this video, you will learn how to find the derivative of a reciprocal functions with rational exponents and the chain rule. Now let's start with the derivative of a reciprocal. The derivative of a reciprocal is given by the formula dy over dx is just equal to the derivative of 1 over v with respect to x, where v here is the function. This is just equal to the negative of the derivative of v with respect to x over v squared. Now let's try solving some examples here. So let's say we're given this function y equals 1 over x plus 3. Now we need to find the derivative of y with respect to x. So dy over dx is just equal to the derivative of 1 over x plus 3 over dx. So take note here, our v is x plus 3. So this is just equal to the negative of the derivative of v, which is x plus 3 with respect to x over v squared. So this is x plus 3 squared. So this is how we write the derivative of a reciprocal. And in this case, we're given the function 1 over x plus 3. Now let's further solve this. So this is just dy over dx is equal to the negative of derivative of x plus 3. So derivative of x, that is 1, plus the derivative of 3 is 0 over x plus 3 squared. Therefore, the derivative of the function 1 over x plus 3 is just equal to negative 1 over x plus 3 squared. So this is our final answer. Now let's solve another problem. Let's say we're given this function y equals 1 over 5x squared plus 3x minus 1. And we need to find the derivative of y with respect to x. So this is just equal to the negative of the derivative of v. V here is 5x squared plus 3x minus 1 with respect to x over v squared. So this is 5x squared plus 3x minus 1 squared. And this would become the negative of, alright, so we have here a constant and a function. Derivative of that is 5 times 2 times x to the power of 2 minus 1 using the power rule. Plus derivative of 3x, this is 3. And derivative of 1 is 0 over 5x squared plus 3x minus 1 squared. And this would become, let me erase this. Wait. So dy over dx is just equal to the negative of this one. 5 times 2 is 10. 10x x to the 1, or just simply 10x plus 3 over 5x squared plus 3x minus 1 squared. So this is now the derivative of y with respect to x. Now we don't need to expand this or distribute the negative sign to 10x plus 3. Now let's discuss the derivative of a function with rational exponents. So this can be done by using the formula dy over dx equals the derivative of a rational function, or function with rational exponent, let's say x to the 1 over n with respect to x. So this is just equal to 1 over n times x to the 1 over n minus 1. So this is just similar to the power rule. And take note that n cannot be 0. So where n is not equal to 0. Now let's say we're given this function y equals square root of x plus fifth root of x. Now we can write, we can get rid of the radical by writing this in, so I meant we can write this as an exponential, into an exponential form. So we can write square root of x to the 1/2 plus fifth root of x as x to the 1/5. So take note here that when we write the radical into a exponential equation or into its exponential form, the root, let's say here square root, that is the root is 2, that would be the denominator of the exponent. And in this case we have fifth root. That's why our x here is raised to the power of 1/5. Now we get the derivative of y with respect to x. So we can use the power rule here. The derivative of x to the 1/2 is just 1/2 times x to the 1/2 minus 1 plus 1/5 the exponent times x to the 1/5 minus 1. And this would be dy over dx equals 1/2 times x. 1/2 minus 1 is negative 1/2 plus 1/5 times x. 1/5 minus 1, so that is 5 divided by 1/5 times negative 1 is negative 5. So this is x to the negative 4 over 5. And since we have a negative exponent here, so we can write x to the negative 1/2 as 1 over x to the 1/2. So this would become 1/2 times 1 over x to the 1/2 plus 1/5. We can write x to the negative 4/5 as 1 over x to the 4/5. So this would become, okay, let me write that here. So dy over dx would become 1 over 2x to the 1/2 plus 1 over 5x to the 4/5. And we can just simply simplify this further. This would become 1 over 2 square root of x plus 1 over 5 fifth root of x to the 4th. So this is our final answer. Now let's try another problem. Let's say we're given this function y equals the cube root of x plus the fifth root of x squared. So again, we can write this in its exponential form. So we can write cube root of x as x to the 1/3 plus fifth root of x squared is just x to the 2/5. Then we differentiate, we get the derivative of y with respect to x. So this is dy over dx is just equal to 1/2 using the power rule times x to the, oh, this is 1/3, sorry. So 1/3 to the 1/3 minus 1 plus 2/5 times x to the 2/5 minus 1. And this is just 1/3 x to the 1/3 minus 1. 1/3 minus 1 is 3 divided by 1 is 3 times -1 is -3. So this is -2/3 plus 2/5 times x to the 2/5 minus 1, 5 times 1, -5. So this is -3/5. And we can simplify that. We have negative exponents, right? So dy over dx is just equal to 1/3 times, we can write x to the -2/3 as 1 over x to the 2/3 plus 2/5 times x to the -3/5 can be written as 1 over x to the 3/5. Then this would become 1 over 3 times x to the 2/3 plus 2 over 5 x to the 3/5. Then we can simplify this further. So this is just 1 over 3 cube root of x squared plus 2 over 5 fifth root of x cubed. So this is now our final answer. Now let's discuss the chain rule. So the chain rule is a bit complicated, and the formula for chain rule is just dy over dx equals dy over du times du over dx. Notice here that we added du. So when we multiply dy over du and du over dx, du simply cancels out and we'd be left with the same dy over dx. So how can it be? So let's say we're given this function. Say for example, we're given y equals 5x squared minus 3x plus 2 cubed. Now, given this function, we cannot directly derive this, so we need to use chain rule. And to use chain rule, we need to identify the value of u in the given function. So we're given here the function y equals 5x squared minus 3x plus 2 cubed. And to find u here, we can use this function. Okay. Inside the parenthesis, that is raised to the exponent cube. So u here is just equal to 5x squared minus 3x plus 2. Then we can employ the chain rule formula. So first we need to find dy over du. Therefore, our function here would become y equals u cubed. Alright, so we find dy over du. And dy over du is just the derivative of y, or the function u cubed, with respect to u. So we use the power rule. So this is just 3u to the 3 minus 1. So this is just 3u u squared. So now we already have the dy over du. Let's delete this. Now we can solve for du over dx. So du over dx is just the derivative of ru. U here is 5x squared minus 3x plus 2 with respect to x. Alright, so this is just the derivative of each of the terms. 5x squared, that is 5, a constant on a function, times 2 times x to the 2 minus 1 is x to the 1, minus the derivative of 3x is 3, plus derivative of 2, which is a constant, is 0. Therefore, du over dx is just equal to 10x minus 3. And now we can find dy over dx because we've already solved dy over du and du over dx. So dy over dx is just equal to the product of dy over du, which is 3u squared, and du over dx, which is 10x minus 3. And now we plug in the value of u, or we substitute back the value of u, which is this one. So dy over dx will just be equal to 3 times 5x squared minus 3x plus 2 squared times 10x minus 3. So now this is our final answer. So the derivative of this one, this function, is equal to this one. Now let's try another problem. Let's say we're given y equals the square root of x squared minus 5x plus 2 cubed. Alright, so we need to find u here. So in this case, our u would just be this one, the function inside the parentheses, or the radical, the one that is raised to the exponent 3. So u here is x squared minus 5x plus 2. And now we can solve for dy over du. Oh, hold on. So our function would become y is equal to the square root of u cubed. So dy over du is just the derivative of what's this? A square root of u cubed with respect to u. Right. So this is a radical expression. We have a square root, given a square root here, so we can write this in exponential form. So we can write square root of u cubed as u to the 3 halves. So this is basically just the derivative of u to the 3 halves. This is derivative of u to the 3 halves with respect to u. And we use the power rule, so this is just 3 halves times u to the power of 3 halves minus 1. And this is just 3 halves times u. 3 halves minus 1 is just 1 half. So this is just equal to 3 halves square root of u. Now we already have the value of dy over du. So let's solve for du over dx. So du over dx is just the derivative of u. U is this one, x squared minus 5x plus 2 with respect to x. Then we derive this function x squared, each of the terms. So this is 2x. Derivative of negative 5x is negative 5. And derivative of 2 is 0. So dy or du over dx is just equal to 2x minus 5. So now we already have dy over du and du over dx. We can solve for dy over dx. So du over dx is equal to 2x minus 5. Then dy over dx is just the product equal to the product of dy over du, which is 3/2 square root of u, times du over dx, which is 2x minus 5. And now we substitute back the value of u, which is this one. So that is 3/2 square root of x squared minus 5x plus 2. And this is 3/2 times 2x minus 5. So this is our final answer. Therefore, the derivative of y equals square root of x squared minus 5x plus 2 cubed is just equal to 3/2 times square root of x squared minus 5x plus 2 times 2x minus 5.